Okay, so here is how we're going to do it. This is just a diagram from the Brewing Science laboratory handbook that I highly recommend you get. This is what the hemocytometer looks like. It's divided into these 3x3 that each has, I think it's 4 or 5x5. It looks like 5x5 boxes within it. So we're going to go ahead and if you do it the long way, you count all boxes like that. Or you go ahead and do the short one, you count a corner, another corner, the center, and then the two opposite corners. To do the math on it, you can either follow this formula it says right here, or you can go ahead and use my yeast pitch calculator that I've made. And here you can see an example of when I have counted live and dead yeast cells. So again, the live yeast cells are the ones that are white and the dead yeast cells are blue. So I went ahead, for example, if we did a short one and counted 44 cells, yeast cells that were white in this corner, 27 here, 44 there, 53 there, and 44. That was total yeast count, yeast cell count. Then I went back and counted only the ones that were dead, which are the ones that are blue. But remember, you do not count the ones that are blue if they are budding, because they will always stay in blue. So here I found 6, 2, 4, 4, and 2. Then you can see the percentage viability, how many are alive in the different quadrants. If you count all of them, that's the long way around. It's more accurate, but it takes a lot more time because you have to count all of these right here. Okay, from there, go down here. Either you enter in the dilution factor in the longhand section or the shorthand section. I'm going to go ahead and focus on the shorthand since that's most likely what you're going to be doing. So most of the time you do a 100 dilution factor, which is again the 10 to 1, and then take 1 milliliter from there and put it in another 9 milliliter, which gives you another 10 to 1. The 10 and the 10 multiply together, and that's 100 dilution factor. So you go down from there and you can see your viability. You want to have at least over 90%. 95 is ideal. In this case, it was 92. Then in my calculator, you go ahead and enter in the wort size in gallons. This calculator is just set up that way. So let's say it was 10 gallons. And then it will convert over to what that is in other measurements for you. Then if you're going to make a regular ale, you might want 1 million yeast cells per milliliter per degree Plato. If you are doing a Hefeweizen, you might want a little bit less, maybe 0.5. If you're doing an ale, probably 1.5 or even higher. Excuse me, a lager. If you're doing a lager, probably 1.5 or higher. Then you enter how many degree Plato it is. Let's say we had a beer that's about 1040. That is approximately 10 degrees Plato, so we'll leave it at 10. Then that's really all you have to do. Then it spits out the answers. It says how many yeast cells you need total, and then just divide it into billions because I have a hard time reading these numbers. The yeast slurry to pitch says 585 milliliters or 5.9 deciliter or 0.59 liters. So that is one way to do it. However, I would always want to go with a gram scale if possible, or any kind of scale. So here you go. It is 631 grams, 0.63 kilos, or 1.39 pounds.